Hello, everyone. In this lecture, we're going to look at the example of bootstrapping. Okay, bootstrapping is a resampling technique with replacement. So sampling can be with replacement or without replacement. So with replacement means, suppose we draw 10 cards. So we put 10 cards in this hat. We can draw 10 cards at random from the deck. But after each draw, we put the card back in the deck and then shuffle the cards. So sampling without replacement, then you draw 10 cards at random from a deck of 52 cards without putting any of the cards back into the deck between draws. So this is a difference between with replacement and without replacement. For bootstrapping, it's a resampling technique with replacement. That means every time you draw a number, you put it back. So assume a small data set. This is 3, 5, 2, 1, 7. Now estimate the sample mean using the bootstrap samples. So we know if we know this, if we have this data set, we know the sample mean. Okay, the sample mean will be 3 plus 5 plus 2 plus 1 plus 7 divided by 5, because you have 5 numbers. This actually equals to 3.6. You may say, I have already got sample mean. Why do we need to use bootstrapping samples to estimate sample mean? This is because this example focuses on a small data set. Suppose you have tens of thousands of data. Now you only need to draw a number of samples to estimate the mean, okay? And also, if you have the data set and you split them into k-fold, and how do you do the random sampling, okay? And then estimate the errors. So here is estimate the mean. Now, let's see how to estimate the mean without doing this computation. Okay, suppose let's put 3, 5, 2, 1, 7 into this hat. Now we're going to randomly draw it. But whenever you got a number, you put it back. Okay, the first bootstrap yields, like you randomly draw it from the hat, you got 7, 3, 2, 3, 1. Now you can get the sample mean. This sample mean will be 3.2. Now suppose let's do the second bootstrapping. This will be 5. Let's put the first one, 1, 1, 3, 7. So you got the first bootstrap sample from the hat. If you got a 1, you put it back to the hat, and next time you can still has a probability to draw 1, right? So this one, the mean will be 3.4. And what is the third? Now let's do the third bootstrapping sample. This is 2, 2, 7, 1, 3. And for this one, we get 3.0. Now, what is average of these three estimates? That is 3.2 plus 3.4 plus 3.0 divided by 3. This equals to 3.2. Okay. Now, you can continue to draw the bootstrapping samples. Okay. Now, if we only draw the first bootstrapping sample and the second and the third, now we got the mean estimate. This is a little bit away from the true sample mean, 3.6. Now, what is the bias? The bias is actually 3.2 minus 3.6 equals to minus 0.4. What is the variance? Variance is actually 1 over n minus 1, 3 minus 1, because we have 3 numbers. So 1 mu hat first estimate, mu hat second estimate, mu hat third estimate. Now we are going to do the first one, 3.2 minus the sample mean. This one minus sample mean 3.2 square plus 3.4 minus 3.2 square plus 3.0 minus 3.2 square. So this will be the variance. It's about 0.04. So this give us this example give us an idea how to bootstrap from a data set. Okay, from this data set, how to bootstrap. It is with replacement, and then based on the bootstrap samples, how do we do the estimation? And then what is the bias of the estimation? What is the variance of the estimation? So we have done this exercise for the sample mean. So you could trace the computation. Okay, now we do this because we want to show you how to trace the computation. Now we could use Bootstrap to estimate other statistical operators, for example, classification errors. Sometimes people may ask, here you only have, here we have 3 Bootstrap samples. Okay, here we have 3 Bootstrap samples. Now, how many Bootstrap samples should we use in order to have a good estimation? As a rule of thumb, several hundreds resamples will suffice for most problems. Okay, so here we have 3. You can do hundreds of them. Then the estimation will be asymptotically converge to the 3.6. Okay, so this is an example of bootstrapping and how to do the bootstrapping. How many bootstrap samples we need to estimate the particular statistical operator, including mean, classification errors, and error rate, those kind of statistical operators. Okay, so this is the end of this example.